our notes are going to be, our objective, excuse me, our objective is going to, we're going to continue working with equations, but this time we're going to understand how to solve equations with variables on both sides. Okay. Now, I believe Mr. Johnson put together a study guide, so I'm going to attach that to tonight's homework so that you guys can go back and review. I don't know if he put on there, and I'll have to double check. I think some of you are not super clear with your integer rules, and that's tripping up a lot of you with getting sign answers wrong. So I would recommend that you go to Virtual Nerd or you go to Khan Academy if you're struggling with positives and negatives and deal with integers, okay? If your issue is fractions and decimals, again, you can go back to both places and practice fractions and decimals, especially multiplying and dividing, adding and subtracting, okay? All right, so that's our big thing, is to understand how to solve equations with variables on both sides. So we're going to get more and more complex in these equations. So first thing we're going to do is, I'll bring my little guy up here. You may have the same situation that we had before. So here's the hard part, is that there's times when we call things like terms on a side, and then there's things that are like terms on opposite sides. And how we deal with them, whether they're on the same side or opposite sides, is actually not the same way. When they're on the same side, we do the same math we see. I saw a lot of people on the quiz do opposite operations. When they're on the same side, you don't do that. You just combine them, whatever it tells you to do. But when you want to take something across or opposite the equal sign on the other side, that's when you have to do the opposite operation, okay? So the process is going to stay the same regardless of the complication of the equation. Number one, we need to simplify each side of the equation first until there are no more than 2 terms per side. Now, there were questions that we saw on prior homework assignments where there was only 2 terms on a side. Aaron, we're taking notes, bud. There were only 2 terms per side, but the 2 terms were like terms, so we still needed to combine them, so we ended up only having 1 term left, okay? So we need to simplify each side of the equation first until there are no more than 2 terms per side. So what are some things that you might see on a side that's going to require you to simplify it first before you can start getting stuff going on the other side of the equal sign? So what's one thing, Justin?
Parentheses.
So we may need to distribute to remove parentheses. And the reason why the parentheses are there is because there's a variable having math done with some number, and we can't do that. So the only way to get rid of the parentheses is to distribute whatever's outside. Key to watch out for, if what's outside is a negative, you need to make sure you do that. Take care of and distribute that negative as well. Jacob. Generally, these problems are not going to have exponents in them. Okay? You didn't see anything like that on homework. What was the other major thing that would give us more than 2 terms per side? What was the other thing that you saw happen in your equations from homework that you've been working on for a week? Oh my goodness, folks. We wrote this already in your other notes on 2-step equations. You might want to go back and look at that. The other thing we might have to do is combine like terms. Like terms are same variable to the same power. And right now, we've just been seeing equations where the power is just 1, so we just have x's or we just have y's. Or it could be constants, and remember, constants are just numbers, no variables attached. Okay. Aaron, you're supposed to be taking notes. All right, so at this point, after I've done these two things, I should have no more than 2 terms per side, and the 2 terms that I see on a side are not like terms. So it's going to kind of look like that example question we started with, that 4x plus 7 or whatever it was equals 3 minus whatever, 2x. Okay, so once we do that, now we're going to do opposite operations. But this time, we for sure have 2 sets of things we're going to do, because we are going to have variables on both sides. We are going to have constants on both sides. So just out of habit, I always systematically pick one that I always deal with first. And so I try. The variables is the very first thing I always do. So I'm going to either add or subtract, depending on what the opposite operation is, to get variables on the left. Okay. I want my variable to be on the left in my answer. Again, on the quiz, I saw a lot of people not put the variable in the answer on these equations, and that's a mandatory thing because the equation demands you to solve for a particular variable, so you need to tell what you're solving for. And then you're going to do add or subtract, whatever the inverse operation is. Jacob, we're taking notes. To get constants on the right. Okay. Once you go through that process, you have a one-step equation where it's going to be something like 3x equals 6. So I'd have to say 99% of the time, you are going to end up dividing by that coefficient, the number in front of the variable, in order to get the variable alone. Okay? So that would be, is everybody good? All right. So the fourth step, and again, 99% of the time it's going to be multiplying, but it could be dividing. So you're going to, for your last step, multiply or divide both sides by the coefficient in front of the variable. Now, if the coefficient is 1, you obviously don't need to do this step, right? We do have a particular answer format. And you will, whatever the variable was in that problem is going to be equal to the answer. And that will be a number of some sort. Right now.
What if it's a word problem?
Okay, word problems follow different rules. Because in the word problem, it doesn't tell you to solve for X. It says solve for the number. Solve for how many hours she worked that week. So there is no variable, so you don't give one back. That's why we're writing our answer as a sentence, because that makes more sense in a word problem. Okay? And then the only last thing that I'm going to give you, and I'm going to kind of yell at you a little bit, is you got to watch your signs. 95% of all math errors come down to signs. Okay? So we got to figure out how to eliminate that from happening. So what we're going to do is the directions you're going to see in your book are going to ask you to solve, but I'm going to throw in, you need to also check. I can tell some of you decided checking on their test from yesterday wasn't important, so you got wrong answers and you could have prevented that if you'd gone back. And you need to show all work. Also had a weird thing, I had a couple people with good answers, but the work that they had didn't support their answers at all, so that always looks a little suspicious. So work is not to be done in your head. That's not where we get to do it. I know it took forever to come on, I know. So here's our first one. 2x minus 2 equals negative 3x plus 3. So again, I'm going to constantly solve it with variables first and to the left. Even though Samantha was right, you could take the variables to the right. The problem is your answer's not in the right format. And if you do that and you're dealing with inequalities, you'll be backwards in everything you need to do. So this is just a good habit to go. So we're going to take this guy, and he's going to go this direction. So I look at his sign. What's the sign of the 3x? Negative. So the opposite would be positive. So we're going to actually add 3x to both sides. That's what I mean by get it to go to the left. So we get 2x plus 3x, signs are the same, so I add. So I get 5x minus 2 equals 3. Now I want to get the constants to the right. So I'm going this direction. So I look at the 2. What kind of sign does he have? Negative. So the opposite would be positive. So we're going to add 2 to both sides. And that gives us 5x equals 5. So what's my last step to solve the problem? Anybody?
Divide.
Yeah, the opposite of multiplying by 5 would be dividing by 5. And we get x equals 1 as our answer. Okay? Okay. I'm sorry?
What about the positive 3?
The positive 3 got added to the positive 2. Okay. Casey, question?
No,
Okay. So if you were going to do a check, you would just be doing this. 2 times 1 minus 2, does that equal negative 3 times 1 plus 3? So I get 2 take away 2, and I get negative 3 plus 3, and I get 0 equals 0. Does 0 equal 0?
No, it doesn't.
Really? You have no idea what I'm talking about because you're too busy talking to people behind you. Turn and face forward. 0 equals 0. Number is the same. So what that says is that we just checked and said, yep, x has to equal 1. That's the power of doing a check, is to make sure you have the right answer. All right, let's do another one. Everybody good? 7y plus 5 equals 2y plus 10. So again, we want to take the variable to the left, so we look at its sign. The sign of 2y is positive, so the opposite is,
Subtract.
yeah, so we're going to subtract. We're going to have a negative. So we get 5y plus 5 equals 10. We want the constants to go right. So the opposite of a plus 5 would be a minus 5. So we're going to subtract 5 from both sides. And we get 5y equals 5. I know, isn't that weird? It's not always the case. Divide both sides by 5.
Yeah.
Yeah, wouldn't that be nice? Every answer was 1. You didn't have to think about it. Yes?
What if the equal 5? Would that be negative 5?
No. 5 take away 5 is 0. 10 take away 5 is positive 5.
It would be like minus.
Yeah, we're just subtracting. Okay. So again, you can do the check. It's real easy. I'll do them underneath here. So the check, we have 7 times 1 plus 5. Question is, does that equal 2 times 1? Oops. I didn't need that extra one. That's okay. Plus 10. So I get 7 plus 5 equals 2 plus 10. And I get 12 equals 12. Is 12 equal to 12? Yep. So that just verifies that y has to equal 1. Okay. Let's look at another example. We're going to make it a little bit longer. 6m plus 5 minus 7m equals 10 minus 5m plus 3. So how is this problem different than the other two? Caleb. I got 3 terms per side, which means I have to look for some like terms. Do I have any like terms on the left? Yeah, what do I got? My m's are the same. So I'm going to do the math that tells me 6m minus 7m. Careful. negative 1m. Okay, that's what I get left over, plus 5. What about on the other side? What do they have that's the same?
5s.
The constants. So I have 10 plus 3. What's 10 plus 3? Signs are the same, so I add and I get 13, and then I have minus 5m. At this point, each side is simplified. There's nothing more I can do to each side. So now I'm ready to do opposite operations. Okay, Kim?
You bring the 5m to the
Exactly. I'm going to go that direction with the negative 5m. So the opposite of a negative 5m would be a positive 5m. So I'm going to add 5m to both sides. So that gives me, let's see, 5m take away an m is a 4m. And we're left with 13 only on the other side. Okay? And now we need to get constants to the right, so the opposite of plus 5 is subtract 5. And we get 4m equals 8. And then the last step is
5,
divide by
4.
4 to get the m alone. Hey, we didn't get 1 again.
Well, it's almost done.
Close to 1. Okay? And again, you can do the check. The check just gets a little bit longer because there's more numbers to contend with. So I'm going to, for time's sake, I'm going to skip over the check on this one because I want to make sure we get one more in here. And here's our last one. No, it's very similar to the last one. Actually, it's a little easier than the last one. So you got to be flexible in that you need to think about things that are on the same side. You got to do the same math. And then things that are on the opposite side, that's when you need to do the opposite operation. Okay? All right, so looking, do I need to simplify any side?
The 5 and the 4.
Yeah, if you look at the right side, I have 3 terms, and so it turns out that my like terms happen to be variables again. Okay? Now, I did nothing to the right side, so I just bring it down. What's 5n take away 4n? 1n. And now I have no more than 2 terms per side, no more like terms per side, so I'm ready to do my opposite operations. Okay? Cam?
You bring the 1n to the 3n.
Yes, we're going to go left with the n's. And so what am I going to do to get the n to go to the other side? Taylor?
Subtract and up.
Ooh, nope. I'm not going to subtract 3n because then that's going to take him away.
Well,
No?
minus 4n.
I've got an n, and I want him to go the other direction. So what's the opposite of positive n? Negative n. He's the one that I'm going to change. So then that gives me 2n minus 15 equals 3. Now what I want to do is get the constants together on the right. So the opposite to subtracting 15 would be adding 15. So 3 plus 15 is 18. And then my last step? Divide by 2. Not n. Ooh, don't divide by the variable. And 18 divided by 2 is? 9. Okay? And that would be your answer. So a little bit more complicated than the problems from before. And so now you have time to work on homework.